Welcome to this presentation on the practical value of differential somatic cell count. I will start my presentation with a general introduction to the subject mastitis. Then I will focus on the technology behind differential somatic cell count, very briefly only. And in the main part of the presentation, I will be talking about the actual practical application of the new differential somatic cell count parameter. Mastitis is mainly caused by bacteria, and it is defined as the inflammation of the mammary gland. It is a very challenging disease to work with because it is multifactorial, and the environment, the keeping conditions, the feeding of the cows, they all come into play when we talk about mastitis. And it's really difficult to control all of them and provide an ideal environment for the cows. Mastitis diagnosis as such is based on somatic cell counts and also based on bacteriological testing where the actual mastitis causing pathogens are identified. Signs of mastitis can be different. In case of clinical mastitis, we can fairly easily detect flecks in the milk of the cows. So there are some very apparent alterations in the milk. And when we talk about subclinical mastitis, the cows are infected, the cows are actually sick. However, there are no changes in the milk, and the milk of subclinically infected cows looks exactly the same as the milk of healthy cows. So it looks completely normal. And this is actually a huge challenge working with mastitis because subclinical mastitis is the most prevalent form of mastitis, and it's very difficult to detect on the farm as such. Thus, the annual losses due to mastitis still account to somewhere around 32 billion euro every year, and this figure illustrates very clearly that the dairy industry is suffering a lot from mastitis. One approach to manage mastitis is by analyzing milk samples and extracting different parameters out of the milk samples. So we can use the milk analysis as a tool to provide dairy farmers with valuable information to manage their cows. Somatic cell count was one of the first parameters to work with, and is a key parameter in managing mastitis still today. This all started back in the 1970s, but again, it is still a very solid system for mastitis management around the world. More and more parameters were added over the years. For example, urea for feeding management, BHB and acetone for managing ketosis. And in 2016, we have launched a new differential somatic cell count parameter. What exactly does that mean? Well, there are different types of cells in milk. The majority of cells in milk consists of lymphocytes, polymorphonuclear neutrophils, and macrophages. If we investigate them under a microscope, we would be able to distinguish between them because of different morphologies. But besides different names, different morphologies, they also have different functions in milk, which I would like to explain here. So we have if some cows are healthy, somatic cell count would be low, perhaps around 50,000 cells per milliliter, and the cells consist mainly of macrophages. The function of macrophages is to do surveillance. So if it comes to an infection by bacteria, the macrophages would notice that and then initiate the immune response, which means a lot of cells are recruited from the bloodstream into the mammary gland. And a lot of cells here means it is mainly PMNs, so these polymorphonuclear neutrophils, and their function is simply to eliminate the bacteria. High amounts of PMNs in the milk also means that we have high DSCC results. Once the PMNs succeeded to eliminate the bacteria, the somatic cell count starts to decrease and macrophages take over again. In this stage of the infection, the macrophages have the function to basically clean up, to remove broken cells, broken bacteria, and they start repairing the other tissue which might have suffered some damage from the inflammatory reaction. In the last stage of the infection, we see somatic cell count returning to normal levels and macrophages with surveillance functions predominate again. The lymphocytes that I mentioned on the previous slide, they only play a minor role in this in this process. About the technology, the instrument where we can analyze the differential somatic cell count parameter on is called Somatic 7DC. We launched it of the CombiFos 7DC, which consists of both Milkoscan and Somatic. And this technology can analyze up to 600 samples per hour. What exactly is done on the instrument? Every cell, every particle that is in the milk is sent past a laser, and then the laser light is broken by the particles, by the cells passing it, and we have two different detectors called FL1 and FL2. FL means fluorescence channel, and in these channels we are measuring light of different wavelength. We are staining the cells, and thus we get a picture like here. The gray dots here resemble background in the milk, such as bacteria, fat and fat globules, for example. And given that the cells are specifically stained, we get a strong signal from them, and our instrument can identify them in this box up here. And given that we analyze a specific volume, a defined volume of milk per sample, we can calculate the number of cells per milliliter. In a second step, the instrument specifically looks at the cells that we found. We are working with that were found in step 1. We are working with different levels of magnification, and then get basically two different cell populations, an orange one down here and the gray one up there. And because the morphology of the cells is different and we are utilizing these differences in morphology with our staining, we can identify macrophages up here and the PMNs combined with lymphocytes that have a minor role, as I explained previously, in the lower area of the plot. So, and what we find below this orange differentiator here is what we consider as differential somatic cell count. Thus, the instrument produces two values: one, total somatic cell count, for example, 100,000 cells, and then DSCC of, for example, 80%, which means that in this sample we found 100,000 cells per milliliter and 80% of them are PMNs and lymphocytes. A bit more than 1 year ago, we have obtained the full ICAR instrument validation, and the instruments Somatic 7 DC, Milkoscan 7 RM, and Somatic 7 were the first ever instruments that obtained this newly introduced ICAR milk analyzer certificate. And we are very proud to have this, and that we successfully completed this process. Now, I would like to talk about the foundation for working with differential somatic cell count. In a first study, in a first study that we ran in collaboration with Lactanet in Canada, we analyzed milk from more than 1,000 cows. And when I say analyzed, then I mean we analyzed it for somatic cell count, differential somatic cell count, and also the bacteriological status. So we had the reference other health status of the cows available. We worked with a total somatic cell count threshold of 200,000 cells per milliliter and found that in 78% of cases, we can identify sick cows as sick when we work with somatic cell count only. When we use the combination of somatic cell count and differential somatic cell count, which means we are working with a somatic cell count threshold of 200,000 cells per milliliter and a DSC threshold of 65%, and thus a cow with, for example, 150,000 cells and a DSCC result of 80% would also be classified as infected, as sick. Then we find 92% of sick cows as sick cows. So we have an improvement of 18%. And in other words, we are 18% better in identifying sick cows as sick. We have published a full study in Preventive Veterinary Medicine, and you're welcome to investigate this article for further details. In the next step, we developed a so-called other health group concept. Here we worked with the thresholds of 200,000 cells per milliliter and again 65% DSCC to define 4 different groups. These are A, B, C, and D. In group A, the cows are below the SCC threshold and below the DSCC threshold, and thus we don't see any kind of indications for the cows being sick, being infected based on the cells in their milk. In group B, we are still in the low somatic cell count area, but based on DSCC, we already see some activity in terms of the immune system, a lot of neutrophils, and as I explained earlier, the neutrophils are there to fight bacteria, and this is what we see in group B. So these cows are considered to be in the early stage of mastitis. In group C, we have both high SCC and high DSCC, so we have an active inflammatory reaction ongoing there, and we define these cows as having mastitis or having subclinical mastitis. And then group D, here we have high SCC but low DSCC, and we see that these cows tend to be chronically infected. The SCC threshold of 200,000 cells per milliliter is based on recommendations by IDF. In terms of the DSCC threshold, we have done some so-called optimal cut point analysis in the study from Canada and identified 65% as ideal there. This other health group concept is also published in the article shown here. And more interestingly, in this article, where we had almost 1 million test day records available from 5 different countries, Austria, China, Estonia, Germany, and Spain, we looked at the performance of the dairy cows in the 4 different other health groups. And I brought the results from Estonia as an example here. what we found was that cows in group A were most productive, had the highest daily milk yield. Cows in group B were slightly less productive, 2.4% less milk there. And cows in group C and D were clearly less productive. In the discussion of the results, we agreed that the cows in group B produce less milk because their immune system is active. There are a lot of PMNs in the milk, which means that they are fighting something. And when these PMNs are in the milk, when the immune system is active, it consumes a lot of energy. And this energy is then in turn not available for milk production. And thus the milk yield of the cows is lower. Cows with high somatic cell count were known to produce less milk before. This is nothing new. Our findings just confirm that. But what is really interesting here is that there's a huge difference in terms of cows being in group C or D. With the cows in group D having a almost 40% less lower performance than cows in group A. The explanation for this difference is most likely that cows in group D have chronic infections, and if cows have chronic infections, the bacteria often destroy the milk producing tissue, and thus there's simply less milk producing tissue available to produce milk. So these cows have suffered some severe damages. We also calculated the estimated revenue through milk production based on local milk prices, and we produce the unit here is euro per cow and day, and it follows pretty much the milk yield, where we have a 1.1% difference between cows in group A and B, and then almost less than 10% in C, and more than or 36% less in group D. And our experience is very clearly that when we present these results, in particular, farmers would ask, what can I do to get my cows in group A, and how can I optimize my herd management so that most of my cows are in group A, so my herd is most productive and I get the highest possible revenues. In yet another study, we have investigated the other health group concept again and looked at what cows what are the odds, what is the risk for cows leaving a herd, going for cows being slaughtered. And what we found here was cows in the late stage of lactation have the highest risk to be slaughtered. This is explainable by the fact that if a cow is not pregnant, then the farmer typically keeps her as long as she produces milk, and if the milk yield drops, then the cow is likely to be slaughtered. In terms of the other health groups, it was very interesting to see that cows in groups C and D have very high odds, far higher than those in group B and A, which is our reference, which is what we are comparing to. And these, in particular, these high odds ratios for the cows in group D are yet another confirmation for something being chronically wrong with the cows in group D. This has also been published in Preventive Veterinary Medicine, and I suppose the somewhat more interesting part is what are the odds for cows having somatic cell count above 200,000 cells per milliliter at the next test day. And here we can see that the highest odds were found for cows in groups C and D, This very clearly tells us that once a cow has been sick this month and has high somatic cell count this month, it is very likely that you will also have high somatic cell count in the following month. So in other words, once a cow has been sick, it is quite difficult to get her down to a normal level again, which makes prevention key after all. And then in terms of other health group B, we found it was very interesting to see that cows in other health group B are almost 3 times more likely to have high somatic cell count in the next month compared to cows in other health group A. And this finding is very clearly confirming that the cows in group B are in the onset of mastitis and quite likely or far more likely to develop high somatic cell count in the next month as compared to cows in other health group A. So now to the actual practical application. As of today, DSCC has already been implemented or is about to be implemented in the countries highlighted in orange on this world map. And for today's presentation, I have picked the a real-life example coming from Germany to present the implementation there. What was found in this part of Germany, which is in the eastern part of Germany, was that the average productive lifetime of cows was at 2.3 lactations. And most people in the dairy sector are quite unhappy about this number because they all think it's too low and they are wondering what to do about it. So one thing they always keep an eye on is in what lactation are cows being culled. And here we can see that almost 50% of the cows are culled in either lactation 1 or lactation 2. And this is, of course, far too early. The aim of everyone involved is to have older cows, to have more and more cows in lactation 3, 4, 5, or even higher, because this is when they are really productive and when it's really economic to produce milk. And in another investigation, the culling reasons were looked at. And here it turned out that udder health was the second most common reason for cows being removed from the herds. And thus, the DSCC parameter was very interesting to them. And they saw from the very beginning huge potential to improve the status quo DSCC parameter. So in a first step, we looked at the distribution of cows in the other health groups among all the herds in this part of Germany. And it was very interesting to see that there were a few farms with very low proportions of cows in other health group A, a few farms with very high proportions of cows in other health group A, and the majority of farms was somewhere between 60 and 70%. So what we did was we picked farms from each of these groups, visited them, introduced the DSCC parameter and a new other health report, which I will explain on the next slide. And then we kicked off a pilot phase with the farms back in January 2020. This is the new SEC and DSCC based other health report. So what we can see here is the herd results for the 4 different other health groups in this graph, and then the key of the heart of the report is basically this table, where we get an overview on how many cows are there in each of these 4 different other health groups, What does that mean in percentage? And the percentage results are color-coded in green if the result is better than target, orange if it's between target and average, and the average here is the average of all the neighboring farms. And it would be colored in red if it's worse than average. And we can see the results from the current month as well as from the previous month. So it's easy to compare and easy to see how the development is, and if, for example, something was changed in the previous month, it would be very easy to see whether the change improved the situation or the situation got even worse. As I said, there are some target values here as well and some average values. So this is the report the farmers got access to and we're working with in a pilot phase. And I brought you one example from a farm with 850 cows. Here we can see the development of the proportions of cows in the 4 different other health groups. It was a very desirable development on this farm because we can see a very steady increase of cows in other health group A and a steady decrease of cows in groups B, C, and D as well. And we could explain this positive development based on the fact that the infection pressure in terms of mastitis decreased over time in the herd, and thus more and more cows were healthy and the cows were also more productive. The herd manager explained us that they already introduced some improvements in terms of cubicle management end of 2019 and could see very positive effects based on the new report in detail. And this was a new way for them to document such improvements. And thus they used it to praise their staff and motivate them for keeping up the extra effort in terms of cubicle management. They also noticed that all this resulted in less antibiotic treatments, less wasted milk, and better animal health and performance. So they were really happy with the new information they got through this new report. We had a couple of farms involved in this trial, and we actually saw that the application of the results was quite versatile. On individual cow level, the results were mostly used to do a better monitoring of udder health in fresh lactating cows, to do selective dry cow therapy, and in general to catch mastitis at an earlier stage and act differently with these cows, give them extra attention and avoid that these cows go in the high SEC area. On herd level, the results were used to optimize cubicle management and the milking hygiene. In terms of cubicle management, the main finding was that, for example, working with limestone as disinfectant was seen as key in improving cubicle management, and just by increasing the frequency of applying the disinfectant showed very positive results. We also saw that feeding hygiene was important, and when it was warmer, when the quality of the feed was somewhat lower, we could very clearly notice more problems with cows in groups C and in the long run also D. In terms of herd performance, the farms observed that they actually obtained better animal health when working with this report, and this, I think, is a very nice achievement, in particular in terms of all these discussions about animal welfare these days. The farms noticed that they had higher milk yields, higher daily milk yields, and also very important, they had less antibiotic treatments. So at the end of the day, the farms were able to optimize the herd management, herd health, and got more kilos of milk delivered per cow. So very, very positive finding from this trial phase. I would like to spend, before summarizing my presentation, I would like to briefly talk about selective dry cow therapy. We have performed a study some time ago where we had DHI samples available that were taken in the last 42 days before cows were dried off. And here again, we saw that the sensitivity to identify mastitis at the end of lactation or before drying off using DSCC and SCC was significantly higher compared to working with SCC alone. How to explain that? Here I would like to use this graph. We found that only 12% of cows in udder health group A were infected by so-called major pathogens. Major pathogens such as Staphylococcus aureus or Streptococcus tuberis. In udder health group B, the prevalence of these pathogens was more than twice as high. It was at 26%. And the highest prevalence was actually found in group C at 40%. Group D was at 24%. So we see that cows in groups B, C, and D are clearly more infected than those in A, and the prevalence is quite low in A. The results, once again, were published in Preventive Veterinary Medicine, and here you can find all the statistics in terms of sensitivity, specificity, and so on and so forth. What would this actually mean in practice? Here we looked at a data set, a random data set, and checked in what udder health group do cows fall when they are around 350 days in milk or more. And what we found here, 350 days in milk, because that would be the time when they are dried off. And here we found that 1/3 of the population falls in udder health group A, 23% in udder health group B, 36% in C, and 9% in D. Our thinking is that because of this low prevalence of pathogens in udder health group A, there's no real need to treat these cows with antibiotics, and antibiotic treatment as such could be saved here. In terms of cows in group B, we would recommend that some sort of a check is done, for example, a California mastitis test, and then antibiotic treatment might be considered. And in terms of cows in group C and D, antibiotic treatment would certainly be recommended. But in general, we see this udder health group concept here as presented here as a tool to help reducing the consumption of antibiotics on dairy farms, in particular in terms of dry cow therapy, and use this as a tool where farmers feel more confident to save antibiotic treatment on cows. We have also published some articles on our website, and these articles pretty much describe most of the content of my presentation from today, and the link to get to these articles is here. So you are welcome to have a look at these articles as well. To summarize my presentation, mastitis is very clearly still a huge challenge on dairy farms, and the new SCC and DSCC based udder health report clearly helps dairy farmers to better manage udder health and obtain further improvements there. And what we've specifically seen in Germany was that the dairy cow health was better, welfare was better, performance improved, and in the long run, it is also expected that dairy cow longevity and milk quality will improve. With that, thank you very much for your attention, and I look forward to your questions.